Mechanistic Interpretability. Here is your same structured beginner-friendly content for Mechanistic Interpretability, Beginner Level Introduction. Mechanistic interpretability is a field of AI that focuses on understanding how AI models actually work inside. Most AI models, especially deep learning models, are often called black boxes, means we see inputs and outputs, but not how decisions are made. Mechanistic interpretability tries to open the black box, understand internal computations, identify how neurons and layers work, explain why a model gives a certain output. Examples include understanding why a chatbot gives a specific answer, identifying neurons responsible for certain features, debugging model errors, improving AI safety and reliability. This topic helps beginners understand how to analyze and explain AI behavior internally. What is mechanistic interpretability? Mechanistic interpretability is the study of how AI models process information step by step internally. In simple words, mechanistic interpretability equals understanding how AI thinks inside. Key idea. Instead of
only looking at input means output.
AI researchers look inside the model, analyze neurons and weights, trace how decisions are made. Why it is important. AI systems are used in healthcare, finance, autonomous systems. Without understanding, errors are hard to detect. Bias is hidden. Trust is low. Mechanistic interpretability helps. Call out, improve transparency. Call out, debug models. Call out, ensure safety. Call out, build trust. Basic components, component purpose. Neurons, basic units of computation. Layers, process information step by step. Weights, control signal strength. Activations, output of neurons. Circuits, groups of neurons working together. Example of model. Input text equals AI is amazing. Example of simple processing. If AI in text, print AI. Concept detected. Simple interpretability example Python. Input value equals 5. Weight equals 2. Output equals input value times weight. Print, output, output. This shows how internal values affect output. How mechanistic interpretability works. Step 1. Input data. Input data equals hello. Step 2. Pass through layers. Layer 1 equals input data. Layer 2 equals layer 1. Step 3. Analyze neuron behavior. If hello in layer 2, print neuron activated. Step 4. Trace decision path. Print tracing decision path. Step 5. Explain output. Explained AI in neuron analysis. Understanding individual neurons. Activation equals 10. If activation equals 5, print neuron active. AI in feature detection. Identifying learned features. Feature equals cat. Print feature detected. AI in debugging models. Finding errors in AI. Error equals true. If error, print model issue detected. AI in safety analysis. Ensuring safe outputs. Safe equals true. If safe, print safe output. AI in bias detection. Checking fairness. Bias equals false. If not bias, print no bias detected. Full menu-based example. Def analyze neuron. Value equals int input, enter activation value. If value equals 5, print neuron active. Else, print neuron inactive. Def detect feature. Feature is input. Enter feature. Print feature detected. Def debug model. Issue equals input. Enter issue. Print analyzing issue. Issue. While true, print N1 analyze neuron. Print 2 detect feature. Print 3 debug model. Print 4 exit. Choice equals input. Enter choice. If choice equals 1, analyze neuron. If choice equals 2, detect feature. If choice equals 3, debug model. If choice equals 4, break. else print invalid choice. Check. Neural networks, internal model behavior, feature detection, model debugging, AI transparency, explainable AI. Real-life analogy. Mechanistic interpretability is like opening a machine to see how it works inside. Instead of just press button means get result. You understand. Gears, mechanisms, process, ways to improve a project. Use visualization tools, activation maps, analyze model layers, study attention mechanisms, use interpretability libraries, debug real models, compare outputs, study research papers, build explainable AI systems. Common mistakes beginners make. Treating AI as a black box, ignoring internal behavior, oversimplifying models, not validating explanations, confusing correlation with causation. Where it is used. AI safety research, model debugging, healthcare AI, finance systems, autonomous systems, explainable AI tools, academic research, enterprise AI. Large systems may include deep learning models, interpretability tools, visualization systems, AI safety frameworks. Simple definition. Mechanistic interpretability. The study of how AI models work internally to understand their decisions. Final summary. Mechanistic interpretability helps us understand AI internals, explain decisions, detect errors and bias, build trustworthy systems. It is essential for creating transparent and safe AI systems.